Hi guys, today we're going to continue talking about physical properties of matter, and we're going to focus on the states of matter today. Now the three that we're going to focus on are solid, liquid, and gas. We're not really going to talk about plasma because what we're actually talking about is the kinetic molecular theory. The kinetic molecular theory states that all matter is composed of small particles, such as atoms, molecules, or ions, and that those particles are in constant motion. Also, those particles are colliding with one another and the walls of their containers. I want you guys to write both of these down. I'm not really sure why the first one isn't in green, but write all of this slide down. And if you look here, this shows kind of a close-up of what a solid, liquid, and gas would look like on a particle level. And this kind of gives you an idea of how it fits into the kinetic molecular theory. With this, let's talk about how the states of matter are defined. First of all, the states of matter aren't defined by what they're made of. For example, just because it's made of gold doesn't make it a solid. Alright, let's talk about how we do define states of matter. States of matter are going to be defined by whether they hold a shape and a volume. And a solid, liquid, and gas are going to act differently when it comes to shape and volume. Alright, so for solids have a definite shape and a definite volume. What that means is if you transfer them from container to container, they're going to keep that same shape and that same volume. So if I took a marble in one container and I poured it into another container, that marble is still going to have the same shape and it's going to take up the same amount of space. And that is what makes it a solid. If you look at the particle view of a solid, you guys can draw that picture down there and also write that particles in a solid are packed closely together, and for their motion they vibrate in place. Okay, remember the kinetic molecular theory said that the particles are in constant motion? Even though in a solid they're fixed, they are still vibrating, so they do still have that movement. For liquids, liquids have a definite volume, but they don't have a definite shape. What that means is if you pour them from container to container, you should still get the same volume reading. For example, if you look below, if you pour 100 milliliters of red water from a graduated cylinder to a beaker, that beaker should still have 100 milliliters of water in it. Okay, so they keep their same volume, but they are going to change and adjust to the shape of the container. So the particles of a liquid are packed closely together, kind of like a solid, but they have room to move freely around each other. They kind of flow past one another, but they have to stay in contact because that's how they keep the same volume. I do want you guys to draw that picture of the particles in the liquid below. Alright, gases. Gases have neither a definite shape nor a definite volume, which basically means they take on the shape and the volume of whatever container you pour them into. So if you look below, that is actually bromine gas. And when the container was expanded, you can see that that gas now fills up the entire shape of the container and the entire volume of the container. So that's characteristic of gases. And here's a particle view of the gas. Most of the time with gases, the particles are moving freely and will try to fill up any space that they have, but you can also compress them down. Alright, so now that we've talked about how to define the states of matter, let's talk about changing those states of matter. A quick definition for you guys, thermal energy. When I'm talking about thermal energy, I'm talking about heat. Basically, the rule is the more thermal energy that you add to a substance, the more particle movement there will be. Okay, what that means is as you increase the temperature or you heat something up, you're going from a solid state to a liquid state to a gas state. If you're going the other way and cooling off that substance, you're going to go from a gas to a liquid to a solid. Okay, I want you guys to make note of that. You can write what's in green, but go ahead and draw those pictures and those arrows as well so that you know what it means. Alright, so the melting point occurs when a substance changes from a solid to a liquid. That's called melting. Your melting point is the specific temperature at which melting occurs. And each pure substance has a specific melting point. The one that I want you guys to know is water. Okay, you guys need to memorize the melting point of water, which is 0 degrees Celsius or 32 degrees Fahrenheit. Okay, with the melting point, what happens is the particles of that solid, we're adding thermal energy, so they get more motion, and they start to vibrate so fast that they actually break away from those fixed positions and are able to flow past one another, and that's when they form a liquid. Freezing occurs when a substance changes from a liquid to a solid. The freezing point of water is the same as the melting point. Actually, the freezing point of any substance will be the same as the melting point of that same substance. The difference being that if you're freezing something, it means you're taking away heat, whereas if you're melting something, you're adding heat to that substance. So the freezing point and the melting point of water are both 0 degrees Celsius, and you need to know that. Vaporization occurs when a substance changes from a liquid into a gas. Okay, so again, you're adding heat, so those particles gain so much energy that they start to break apart even further and they form a gas. There are two kinds of vaporization, evaporation and boiling, both of which you should know. Evaporation occurs when you are vaporizing liquid on a surface, and boiling occurs when a liquid changes to gas below a surface, as well as above. Now when you have a pot on the stove, your heat source is on the bottom of that pot. So what happens is that liquid at the bottom of the pot is getting hot and it's changing to a gas. A gas is less dense than a liquid, so it rises to the top, and that's where boiling occurs. So when I refer to the boiling point, I'm talking about the temperature at which a liquid boils. Again, you just need to know the boiling point of water, which is 100 degrees Celsius, or 212 degrees Fahrenheit. Condensation is when you have a substance that changes from a gas into a liquid. Okay, the condensation point of water is 100 degrees Celsius. Notice that it's the same as the boiling point. Okay, it's the same thing with melting and freezing. It occurs at the same temperature, but it just depends on whether you're adding heat or taking away heat. So if you're taking away heat at 100 degrees Celsius, you're condensing. If you're adding heat, you're boiling or evaporating. Okay, and then we're going to look at this curve a lot this year. You need to know it. You can write it down now. If you don't, you will get it in class next time. So if you'd like to, you can write it down. Alright guys, and that does it for States of Matter. Make sure that you fill in your cues and your summary and that you bring your notes next class, and I will see you then.